Hello everyone. We'll start in 2 minutes. Hello everyone. We'll start today's lecture. Hope you guys enjoyed your weekend well and also gone through the lectures. Okay. So in the last class we discussed about majorly about the NumPy. Any doubt in that? And I'm sorry, actually I was not well, so that's why I have shared the PPT, that PDF file so late. And I also wanted to share the assignments like practice questions, but I'll definitely share those things to like after the class. I'll share those things. Any doubt till now? Like we'll discuss this linear thing.
Yeah,
Like
this linear thing only because in the
huh.
last class,
Yeah, I know it was so much in hurry.
yeah,
Uh, so I'll explain that before excluding that. Any doubt? No, right? Okay. So, do you guys remember that, like in a algebra only, in a algebra class or in a mathematics class, we used to solve the linear, like the linear equations or the quadratic equations where the degrees to remember something like ax plus b is equal to something like this. We used to have some such a simple equations back then. Okay, or like mx plus c is equal to y. It was like if yeah, if we have this particular kind of x and y, and this is the line, so equation of this line will be mx plus c, where c was the some constant or slope and like that. So here when we are writing mx plus when we are talking about the linear thing, here we are like simply understand that, for example, if I have something ax is equal to b. Okay, so it is like it does not compute the inverse explicitly, but here what we are trying to do, that we are trying to calculate what x must be. For example, if we have two matrix, okay, a and b, then how we can calculate the x thing? Let's say I have a two simple equations. Okay. First equation is equal to 2x plus y is equal to 5. And x, second equation maybe, let's say x plus 4y or 3y is equal to 6. So here this equation can be written as like this also. Like a equal to 2, 1, sorry, this is matrix I'm trying to write. 2, 1, 1, 3. Wait, let me, okay. Like how this is how we will write. This first letter 2, okay. Then this uh, component of y, or we can say the number before y is 1. Then number before x is 1. And before y is 3. Okay, this is our A, capital A. Okay, this is capital A. Then capital B will be, this is A, and capital, sorry, B, small b, we are using here small b. B is equal to 5 and 6. I don't know how many of you have like have done solving this equation in the matrix class. Like we used to have such a and b, and in that we were told to calculate the x. Okay.
Yes, yes.
Yeah, remember? So now if I have to write this equation in the Python, okay, so this is, we are having the a and b here. For example, if I have to write it here, this two equation in the using the numpy, so how I'll write import, sorry, import numpy as np. Now I have a is equal to np dot array, and it's a 2D array. So 2, comma 1, comma enter, and 1, comma 3. Okay. So this is my A, and my B will be, B is equal to np dot array 5, comma 6 it will be, right? So 5, comma 6.
It will be
Now
5,6 or it will be 2D array.
5, comma 6 also we can write. I think there won't
I
be
don't think so.
like you are telling it to write 5 by 6.
Yeah,
This is a 1 cross 2, 2 cross 1, right?
yes, yes.
We can write it like this only. There, it will consider, I think it will take it. Let's try with 5, comma 6. Let's see what we get.
Okay.
Okay. And now we will write this equation, right? Now this thing will come. So we know ax is equal to b. So how we'll write this? I'll copy this. X is equal to lin alg, that is linear algorithm. Okay. And then solve a comma b, right? So when we'll do this, then we'll say print x. So we'll get a value 1.8 comma 1.4. Okay. So we can now reverse back also and check. So this 1.8, 2 into 1.8 is equal to 2 into 1.8 plus 1.4. Let's say this is A1. Just I'm randomly, or say B1, or simply, and print B1. Okay, so we are getting 5, right? Then you can recheck for the similarly for using 1.4 value. So let's say 1.8, that is x, plus 3 into 1.4. We are getting 5.99 approx equal to 6. Okay, so in this way we'll solve the this thing,
But
linear
here,
algebra thing.
the x 1.8, 1.4
Hmm.
is a 1 by 2 matrix, right?
These are x and y values we are getting.
Yeah, I mean to say, oh yeah, yeah, okay, got it, fine.
Hmm. Okay. Any doubt? Similarly, if you have any, any equation like this, you can easily calculate the this thing, x and y value. Right. So let's move to the next topic. This is the same way, I think. Uh, if you get any equation, let's say any 5x plus y or something like that, you will write it in this way, and then you will, let's say you had a doubt of if we write it like this, like 5 and 6. Okay, we'll check 5 comma, sorry, 6, and I don't think so the values will get changed. Let me run this first. Oh, sorry, that is not supposed to run. That was for just an example, that if we get equations like this, how we'll solve those kind of equations. Yeah. So we are getting now the answer in such way that 2 by 1, the shape will change.
Yeah,
Instead of
this is the
putting,
actual, this may be the actual shape.
the array, yeah,
Yeah.
the X array which we will get, the value is same only. But if we talk about array, it will be like this. Like,
Yeah, now
huh,
it is matching with the
yes.
matrix multiplication
So
model.
this is our A, this will be our X, and then equal to that particular thing will be our B. Okay, like this it will be. And this value will be 1.8 and 1.4. Sorry, I hope you understood. I'm not able to write it. Okay, so now let's move to our next topic, that is pandas. So, any doubt in the NumPy thing? I hope it's clear. The array thing, how to create an array, how to work with the arrays, and all those rules and everything.
Y- yes.
Yeah. So let's move to the next topic, that is our I think I've told about, just a minute. Yeah. So when we talk about, pandas, so we know that pandas is the library which will allow us to work with the, like a spreadsheet like data, or either it's a CSV file, or if we have an Excel sheet. Okay. So what pandas do? Yeah. So it is a library. Pandas is the library that makes us working with spreadsheets, or when I say spreadsheets, CSV, Excel, okay, any tabular format thing, we will discuss it here. Now, in this, there are two type of data structure in the pandas, okay. What are those data structure? One is series and another is data frame, okay. So, two types of, guys, let me know one thing, that do you need a PPT or something, or are you able to understand this thing from the like the file which I am sharing, or do you need separate presentation with all these things written there?
It is more
That would be helpful.
I think PPT is like having syntax of all those things. It will
Hmm.
consolidate all those things in one
Okay.
place instead
Yeah.
of watching this entire document.
Fine. Fine.
Yeah.
Okay. Yeah. I will share with you. Okay. So there are two type of, or we can say two types of key data structure. One is series, that is series, and data frame. So when I say series, it means that 1D thing I'm talking about. Okay. Now, see, when we talk about pandas, we are going to work on the hundred, like many methods, like manipulation of the data, analyzation of the data, editing data. Okay. And when we talk about series, we'll always talk about the one dimensional labeled array. Like you remember, we had the array in the NumPy. So here what will happen, that every element has both value and the index label. Now, why index label is important here? Consider, like when I say spreadsheet, it's mean that it will have the X, it will have the columns, it will have the rows. Okay, so think of it as a single column from a French, this particular CSV file. Okay, so series is 1D labeled array. So when I say labeled, it means that index label, okay? It will have value and index label. Or you can consider it as a single column from a spreadsheet, right? Which will have rows, complete with rows and labels. Now, for I'm not telling to install pandas and all these things. Okay. I hope already understood, like we have taken so many times installing the pandas. Even if you don't know, we can install it here only using pip install panda. Okay, I will write it using pip install. If you have not installed, you can install it using pip install pandas. Since I have already installed, that's why I'm just commenting it out. Now, to import pandas, we'll simply write import pandas as pd, right? So, like I told you, like for NumPy we use MP, for pandas we'll use PD. Now, when I was saying series, okay, let's understand. Let's say I have a array kind of thing, or when I'm saying labeled array, okay, so PD dot series, and here I'll create my list or array. Let's say 20, 10, 20, 30, 40. So what I'm doing, I'm creating a series from a list. So now, when I print this, when I say A, and when I print this, can you see the way now I'm getting the output? It's not the usual way we are getting the list and all these things. Okay, now we are having a column like structure, okay, a spreadsheet like structure, right? We are having a index as 0, 1, 2, and 3, and this 0, 1, 2, 3, and like the pandas automatically assigns the integer label as a 10 to 0, 20 label as a 1, 30 as a 2, and 40 as a 3. So this is how the indexes look like, like the panda series look like in the series when we talk about. So, or you can like simply give any number here, okay? So we are, instead of list, we are moving towards now the spreadsheet kind of structure, okay? Earlier we used to get the data in horizontal way, but now we are getting the data in a series and a column, on a row with rows and column, okay? And each number will have the indexing. Each number will be assigned a position, the same way we used to get it in the like 0 index, first position starting from 0, and then second position starting from 1, okay, like that only we are getting. Let's say this is series S, and let me print. So I'm getting 0 place 100 and like that, okay. Now this is from the list we have created. The any doubt? So we have created a series from a list, okay, this is the list. So we are, sorry, creating series from a list. But if I want to create a series from a dictionary, now when I say dictionary, it means it will be the what? It is a pair of key and value, right? It will have the key and value thing. So create series from dictionaries, right? Now dictionary means our this thing will start from, let's say I have A, or simply DL, right, is equal to PD dot series, right? Let's say I have anything. Let's say I'm writing Delhi. Let's say I'll write rainfall at the rainfall on Monday, Tuesday, and something like that. Okay. So rainfall on Monday is, let's say, 50 mm. Then Tuesday is 100. Okay. And Wednesday is 150. Okay. Now I'll close my dictionary. I'll close this bracket. Let me print this dictionary. So what's happening now? What happened that my Mondays, which are my key, has become the index label. Okay. Now, sorry for the noise. My in the key become the index label. Okay, here what happened? Key became the index. Sorry, index labels, right? And the values become the data. So earlier, in place of 0, 1, 2, 3, 4, now we have the key Monday, Tuesday, and Wednesday, right? And instead of this thing, and instead of the data, like we are having the value. Okay. So this is how.
I want to ask one thing.
Mm,
Uh, like in the result, it is showing D type int 64. Okay.
mm.
What if our data is in string? It will keep working, or we have to do something else?
Let's say it will work, or it will. Let's check. Okay, let's say we write it here heavy. Okay, here low, and here heavy. Now the D type has become object. Okay, the character, like whenever this kind of object means like it will have some, like not a string, not a, no, it's like a string only. Okay, but not a in a integer format.
Okay.
Yeah, so it will not be the float, but some character thing. Okay. So when we talk about in a NumPy or this thing, so it means that this array is not storing now the numeric data. Okay. And that's why it refers to the object, right?
Oh,
So like it can have like when we are having int 64, it's like a number thing is getting stored. And but when no, like when we say about the float thing also you can get, or a string also. Okay. So when we get object, it's saying that the pandas is not storing the numerical type. Okay. Then if, let's say, okay, I'll keep this. For example, if I have to access any label, or like access anything from this particular label. So how we can access by label? To do that, let's say, to access by label. Label means now this index value is our label. Okay, this is the index label. I want to see that what value Monday holds, what value Tuesday hold. Okay, if you want to access by label, not value. So to do that, we'll simply write print D and Monday. So what we are writing? That particular series D, in that D, my label for which I want value to get printed, and I'll print. So it will give the 100. Okay, let's say I make it n and I write it here n. So it will give, no, sorry, D. This is no D only. What did I do? Huh. So now if I change that particular series, and now I want to check that for Monday, which value it holds, which value. So it will print D Monday heavy. Okay, so this is how you access the value by integer. So when we are saying, like this is like a dictionary lookup. It is that we are passing the label Monday to retrieve that particular value, which it is holding 100. Okay, so we are passing the label Monday to retrieve the 100 value. Okay. Now, if you want to, see just what number the whole array holds, okay, so to do that, we can simply write print and n dot values. So the dot values property returns the underlying numpy. So what it will not return the index, but only the numbers, only the value. Okay. So dot values property returns the numpy array. No indexing, no index label, only values or a data or a raw number, whatever it holds. If I want to check what the index property it holds, not a value, but I want to check what are the index property it holds. So I'll simply write print n dot index. So this dot index property will return the index object now. Okay. So Monday, Tuesday, Wednesday, and the data type also it has. Now the data type is the object. So it will returns us the each element of the label. Okay. So dot index returns the index and object type or a data type object, or we can say label for the each elements, whatever the label it holds, it will uh, give that particular. Now we were discussed that in the numpy thing we have discussed the like the conditioning thing, or we can say also we have discussed how like the condition and the arithmetic thing. Let's say how we can do the arithmetic operation over the series. Okay. On series. Now, let's say I want to do n star 2. So when I do n star 2, it will happen that now all the values will get multiplied by 2. Okay, so again here the arithmetic operation series works on the element wise. It works element wise. Element will get multiplied by, each element will get multiplied by 2. If I say n plus 100, so each element will get added to 100. If I say n minus 50, then each element is getting minused by 50, and index is preserved in the result. Okay, index, we will get the same index. We are not touching the index here. We are only multiplying the element wise value, and we are like uh, only working with the values here. Only the values are getting multiplied. Okay. Now let's say the the condition which we used to do. Okay, let's say n, sorry, n. Now, how we can do the Boolean filtering, or how we can do the, like the conditional Boolean filtering and slicing, we'll see that. Just a filtering we'll see, then we'll move to the data frame. So if I do if I just simply do n greater than 120, n greater than 120, so I'm getting the values in true and false. Okay, I'm getting Boolean in a true or false. That particular value, if it is greater than 120, it is true, otherwise it is showing false. Okay, so we are getting Boolean output. If I do n greater than 120, so what will happen now? First, it will check whatever the value n greater than 120s are, and then it will return only the element where the condition is true. So it will keeping their, like all the original label, it will only print the value which where the condition is true. So only Tuesday and Wednesday is getting printed. This is called Boolean filtering on series. Lines, listen. What happened? Okay, this is Boolean filtering on series. Right? So when we say Boolean filtering, it will returns only the elements where the condition is true. Right? So we are only getting Tuesday and Wednesday. Any doubt with the arithmetic thing? Arithmetic same, it will happen element wise, and for the Boolean, there is like if we do just greater than 120 or any value, it will give us the Boolean output. But if you do n square bracket n greater than 120, it will only return the values which are greater than like where the condition is true.
So the initial list will be it will get modified, or it will be remaining the same.
Which one?
Uh, like this, the initial end
N?
in which the result is false, it will
How?
remain the same or it will get changed. I just want
This
to ask that.
N.
Uh, yes.
Same only it is. It is not, it's like keeping our original data.
Okay, okay,
Hmm.
okay.
Because here we are just, like we are not assigning into somewhere, or just, like the condition we are checking. We are not changing the N here.
Okay.
Right? So the original labels and value will be same. Right? Yeah. So, like in a series, we were working on the one-dimensional array. But when we talk about data frame is nothing but the two-dimensional array. Okay. Data, sorry, data frame. So it is a, or we can say it is a two-dimensional table. When I say table, it means that each, it will have a row, column, data structure. Okay. Right? So each row is one observation, each column is a series here now. Okay, each column will hold something, each row will have some observations. So this is the core data structure where we will, like when we have to work with the real data frame, when we say, or a data set. So this is the core data structure we are going to work on. Right? So let's say to create a data frame, or to, if you have any randomly some values, we have, I think we have covered when we have taken the handling with the file. Let me, yeah, here we have taken some example where we have created the CSV file and then we have converted into the data frame. So here we have a simple, we had this, yeah, here we have a simple data set. Okay, sample data set we had with station, lat, lon, and DVI value. And then we have converted into the CSV file. How? Then okay, we have converted that list into table by how we have converted. First, we have converted into data frame, and then we have save it as a CSV, right? So using pd.dataframe station, we have converted that list into the this kind of format. Okay, so if you get a sample data set, you will work on such kind of thing. Or let's say if you have any data frame, for example, tf is equal to pd dot data frame, and okay, so this here what I'm writing, I'm creating a kind of a dictionary, and I'm converting it into data frame, like we have done with that station and that example. Same. Let's say in a, here I have an example like Tokyo, Delhi, okay, comma, Shanghai. Then country will be, let's say, Japan, comma, India, okay, then comma, China. Then any other feature you can add, let's say area, kilometer square, let's say any example, randomly I'm taking 3600, comma, 6700, comma, 3 5 5200, and then comma, I'll close my dictionary. So now what I have created, this is my list, or we can say dictionary. But when I'm saying pd.dataframe, this pd.dataframe takes a dictionary where each key is a column and each value is a list of that column's data. Okay, so now here city is a column and a list of 3 city name, all, like the Tokyo, Delhi, Shanghai. Then country will be another column. In that, these 3 country names will be the that under that particular thing. Now area in square kilometer will be another column. Let's say Okay, we have to import pandas. We have not imported. Module. Okay, sorry, this F galat ho gaya. It will be capital. Now, if I print df, now you can see this city, country, area are our header files or header columns, and below that, in the 0 row, I'll having Tokyo, Japan, and their particular area. If I So this is how you create a columns and rows using the dictionary and using the data frame. So this is now my data frame. Okay. So data frame is what? It's a 2D table, we can say. Okay. It's in the tabular form, right? And it will have a column and row. Fine. Now, if I want to check its how many columns are there, what are the elements are there, or what is the column types, okay? Or we can simply say how many rows or columns are there. So how we can check? Using df dot shape. So it will tell that I have the 3 rows and 3 column, right? These 3 columns and these 3 rows. And then if I write df dot d types, it will tell each value what kind of data type each columns hold. So city is having the object, okay, or the string format. Country is having the object, and the area is having the int 64. So it will print data type of each column. Now, if I want to check that column has a label or not, or like the indexing thing, so or what are the column labels are there. So if I do index dot columns, it will give me the list of column. This is like one of the important, we can say, thing, because when you have more than 100, it happens that you must get a 30 columns or 50 columns, okay, in a one CSV file. So in that time, if you want to, for example, you have air temperature, precipitation, normal temperature, soil moisture, or let's say likewise you have so many values, population, lat, lon, or we can say so many values, and you have to only work on the temperature, okay. But when we see that particular kind of data structure or CSV, it is very hard to find, okay, which are the columns this particular thing have. So using the df dot columns, you can easily print the number of name of the columns you have in that particular CSV, right? Then if I say df dot index, it will tells how many values are there, or how many, like the n number of data it contains, or the range index it will tell that it will start from, okay, it will start from 0 and it will stop from 3. So this is default row index, it is telling me that 0, 1, 2, 3. For example, if you have 1015, so many rows, so you have to, without opening any particular file, you have to check that how many rows are there. So you can, using dot df dot index, you can like get this information that the default row index is 0, 1, 2. So it means that it will start from 0. It is stops at 3. It means the last is the 2. Okay, it's getting excluded. And step is 1, 0, 1, 2, like that we are having. Right? So this is where you can get a general information of your which columns, column name, how many rows are there, or how the data frame looks like. But now we'll start working on the actual CSV file, and we'll see some of the how we can edit that particular file, how to add column, how to work with the nan thing, and all these things. So you remember I've shared one file, input data. So from there we will take one file and then we'll start working on those file. So now the next, any doubt here in the data frame? So now we'll start reading and writing the data. So when I say reading and writing, mostly we'll work on we have Excel, CSV, JSON, Paraquet, SQL, so many kind of, like datas are there. We'll majorly work on the CSV data. Excel also similarly on the way we import Excel or read CSV, the same way we can, I will tell that how we can read the Excel file. Now, I'll do one thing. Just a minute. Hmm. So what I'll do, I'll take this CSV is there. So let's say I want to work on this CSV. So what we will do to first, let's say to read a CSV, what we'll do, df is equal to pd for pandas dot read underscore CSV, and we'll paste this file path of the CSV. To get the file path, I'll right click on this cities and will copy the copy as path. Okay, just click on this, the path will get copied. Then simply paste it. No need to give this quotes also. It will get directly, when we will copy as a path, it will directly come. Just change this backslash to forward slash, otherwise give r here, okay? Or you can just say here, you can just simply say write r here, or change this thing, right? So in this way we will read the CSV file. Now to read the Excel file, how we'll do, we'll simply say df dot pd dot read. Instead of CSV, you will write exe Excel, okay, EXCL. And let's say if I have a data, something data dot, it will be in Excel SX format. Okay. So in this,
Is df equal to or df dot?
oh sorry, df equal to, sorry. Df is equal to pd dot read underscore Excel. The same way, just in place of CSV, we are reading the Excel now. So you will write underscore Excel, right? So this is how, like, you read a CSV means comma separated value file, and it will return a data frame. So simply we can copy paste the file path. This is also you can do, like, you simply, if you, let's say, I don't have an Excel file, but we can convert any Excel file. Let's say the cities copy. I'll save it as a Excel file, save as. Okay, instead of this, I will save as the, where is the Excel? Excel workbook, okay. And save. And where did I save? This is com only. Okay, understood now the how we are, like, reading the Excel file. This way only we'll read. There is nothing. Okay. So same if you want to read the JSON file, so df dot sorry is equal to pd dot read JSON, or you can also use that with open thing which I told you in the file handling lecture. I told you that way also. If it will not work this way, you can like with open read as r as file as f, you can also open the JSON file in that way. Okay. So to open a GeoJSON file this way. Now there is another like a file in a this pandas we can open is there is a parquet file. So it is generally a binary format file. If you get binary means any value, you will get it in a just which will have only 0 and 1. Okay. So to read that, we will simply say parquet and let's say data dot parquet. Generally, it is not that much used in a geospatial. I have never used the parquet file, but I'm just letting you know if you come across any column binary format file, so you can open it using this. Especially, like a CS people and all this thing who have to work on the like some web application or something like that, they must be using. Otherwise, we don't. In the geospatial thing, we don't use, but you must know how we can open it. Now, if you want to like let's say read any particular file, how we can read that? Now we have saved the file, sorry, we have read the file. Okay, but also we can customize everything while reading the file also. Like if I say df, I'm just printing directly the file. Okay. Like I am able to see, okay, it has a city, country, latitude, population, and type, coastal or island it is. Now, another way is that sometimes happens that we get a file with a very, there is no comma separator, or there is no header file, there is no index column ID is, like the properly shown to. So for such thing, there are some options are there. The way from using that we can customize our file. For example, if I say pd dot read underscore csv, and I'll just copy this thing only. Okay, something like this. Okay, so you can give the separator separator is the, like, is comma will be like the, for example, there will be the column wise properly it will be separated. Okay, so this is like a delimiter. So comma is used as the default separator. So comma, or you can use slash. This also you can use slash t in place of this thing. So this is a tab separator file, or any other character you can use. Then comes the header. So if I say header is equal to 0, it means the first row of the file contains the column name. Many times happens that the file does not contain the first, it happens that 2 or 3 columns contains the header. Let me show you one of the file I must be having. Let's say, so see, when I'm saying here no Excel file, I'm not getting. When I'm, this is in a dat format. Okay, I'm opening it in a CSV just to show. Okay, here also there is no. Next, can you see here semicolon, colon, space? Okay, so this is what, this is separators. delimiters which we are using it here, we are using the same way we are using in the Python. Okay, if I use /t, it will be the tab separator. If I use this comma, it will be the that particular which is like, then there will be the space and or any other separator you can give, or I'll just say simply finish. So now here we are having only one column, like one header, but let's say there is a one more column which is having the units of this particular. You must be having that kind of file. I'll tell. I'll just show. Let me open some other files. I'm not sure if this one is open. Huh. Okay. Even yeah, but it is not a. Okay, let me see. Let me just show you. Okay, do not. This is not a correct file. This is the raw file. That's why it is having such kind of language which we will not understand. We have to format this data, process this data. So can you see here? We many of the time we get something like this. Okay, like 4 columns will be only the heading. First will be the column name, then comes the unit, then comes some other things. Okay, so during such kind of file, we can, if I say header is equal to 0, it means the first column will be the um, header file. If I say 1, it means first 2 column will be the header file. If I say 2, that means that if the file contains first 3 row file contains the column names. If I say none, it means there are no column names. Sometimes we get the CSV file which doesn't have a column names. It will be only numbers, the spreadsheet with only the numbers. So it means that header will have none. There will be the no column names. But now for our file, we have header is equal to 0 because we have only one column name. Okay, so we will say 0, right? Another thing is that is index column. So we know that you can here our index column is this one, right? 0, 1, 2, 3. Right? So if you assign, let's say index column is equal to ID. So it will use the ID column as the row index instead of default 0, 1, 2, 3 integer, right? Then let's say is use from this particular file, I only want to use the city and the population column, not country, latitude, type. I do not want to work on that. Sometimes happen that you have a thousands of columns, like here in the file I have so many, 62 counts, but I do not want to work with this LE stick, ET stick. I only want to work with this CO2 data or a H2O data or a flux data, right? So what you can do, you can select only those particular columns. And how you can select? You say, if you say use calls, let's say, is equal to, let's say I only want to use the columns like city and population. So you will write city, comma, population. Right? So it will only be getting, will be only working on this particular columns. Now instead of, now here in the same file I'll show. Now here I have how many rows? I have around 261 or something, kind of 261. Similarly, it is possible that you might be having a file with 1,000 rows, 10,000 rows. Okay, and I only, like here we have a 20 rows and I only want to load only the first 10 rows. Okay, I do not want to work on the next 10 rows. So then here only you can simply write n rows is equal to 10 and comma. So you are seeing that how I'm customizing this file as per my requirement, right? Then let's say you want to handle the nan file. Nan file means the one which has a space value or some missing values or a gap values or some bad values are there, like -9999 or very like the spikes or outliers are there sometimes in the files. Okay, so if you want to handle the nan values, you can say any value. Since we do not have any nan value here, but just I'm telling you, we'll also take the example with the nan value file. Okay, and NA. So this NA here is the like the a string, and in the file it is used to should be treated as a missing value. So pandas already recognizes many null representation. Okay, so no need to like if I'm telling pandas that n/a, so it should automatically understand that okay, I'm talking about the nan values, right? And then will similarly you can customize so many things, right? But I'll be only using these things, and let's say I'll print this. We'll get the error index ID. Okay, we do not have any index ID here. Let's say okay. Let's remove this. Yeah. Now let's print this df now to check. Now see what we are getting. We are getting only header 0, means that we are only using the column city and population and our only above 10 rows. Now let's say if I want to write this data frame to CSV. So how we can do that? df dot to underscore CSV as a output file. Now if I want to, if I'll just simply say output dot CSV and index, I don't want index is equal to false, it will prevent the like the to create any unnecessarily, if I to create any extra avoid any extra column, I'm saying index is equal to false, right? So if I do, if I write like this df dot to underscore output dot CSV, so this result will get saved here in the home. Okay, it will get saved here. Like I have for the batch 4 I have done this, so you can see the output file has got saved here, and here you can open that particular file and see. Okay, now let's see if I want to save the file in the any output folder. So you can click here, you can click here. Okay, here you can click, you will get this thing. Just Control C you do. So you will get the path of the file where you want to save your output. Let's say I want to save uh, in this particular domain. Okay, so I have just simply clicked here and I have done the Control C. So I got this path. Then I'll just simply paste it here and one more backslash. Okay, and then we'll, okay, sorry, this is false. Right? If I don't write anything, if I don't give this index is equal to false, what I'll get? I'll get one extra column with the same 0, 1, 2, 3 like that. Let me save it as a output 1. Okay, so here it got saved. Okay, so we got two files, output and output 1. So I'll show both the file. So here, can you see in the output 1, this is- here you can see this city, Mumbai, Delhi, we are getting like this. But in the output 1 folder, there extra column we are getting with this indexing. We do not want, we already have the row. If you want indexing, you can say true. Otherwise, if you do not want index, you can simply say false, and you will just simply get the starting with city and population. Otherwise, you will get this extra column here, right? So this is how you save the CSV file. I'll just Control Z. Okay. Now, if you want to save the Excel file, or simply df.to underscore excel and output dot xlsx comma index is equal to false, right? In this way you will save. Similarly, if you want to save the paraquat file, same df dot to paraquat, then output dot paraquat. Okay, like this way you can save. No need to work much on the paraquat thing. We are in this geospatial thing, we are not much. I don't think so. Like, you guys gonna write the any binary file, something kind of thing. Okay, so this is how we read and write a data frame. Now, when we load any new data set, it is important to first thing to do is inspect. When I say inspect, to understand that what kind of data we have, okay, before doing analysis thing or before doing anything with that particular file, what type of content our data contains, what is the shape, what is the type of the data. Okay, so, and to inspect these things, we have some inbuilt functions with the pandas. Using that, we can get to know so many things. Okay, for example, now I will wait, I'll run it again because that df got changed. Now we only have the two uh, rows in the df, that is city and population. So let me print once again to check whether I have. Yeah, so now I have the old one. Okay. So yeah, here when I'm doing anything, my DF is getting changed, right? My file is getting changed. So if you want the old one, again run that particular file. Let's move towards the inspecting the data frame. And trust me, this is like one of the important things to do before doing analysis in the data frame. Okay, or working or doing any analysis, you must follow these steps. When we work as an analyst, we do not get a file with a 20 and 5 rows. You will get a file with 1,000 rows and 100 columns. Okay, and you also it's not possible that to read all the columns and all the rows. To check that, okay, do we have the correct data, how the data looks like, what is the content of the data looks like. Okay, what we do, let's say if I do not want to print this whole file, but I only want to check the first few rows of the column. So to do that, if you first few rows of the data frame, not column. So you can use the head. Okay. So let's say I only want to return the first 5 rows. So df.head5 will only return the first 5 rows. And this is always your first call to do after loading the data. Okay, so inspecting the data frame is the must thing to do when we import or when we read the data, right? So what dot head do? It will return the first 5 rows. I have written 5 here, so that's why I'm writing 5. And here I'm writing one more thing, that it's a first call after loading data, and it should, like always we should do, always we can say always your first call after loading the data is to inspecting the data frame. Right, now we have seen that first 5 rows, but I want to check the last 5 rows also. Sometimes happens that in the last five in the last rows now, some of the data might be missing. Okay, you must be having this columns, but you must not be having this, or you must be having extra columns like this. Okay, so to check that, you will say df dot tail, and let's say if I want to print last 5 column, so it will give me the 15, 16, 17, 18, 19. This last, it will return the last 5 rows, not columns. Sorry, I'm telling column so many times, but it's rows. I'm return the last 5 rows. Okay. And this is important to check if the file ends cleanly or has any trailing garbage. You know what happens sometimes? Generally in the CSV file, let's say you have something, any other data, you will have some more file like this, you will have some more data like this, anything, for example, okay, something like this. And if you have not checked your data, and you will have some error, these are like the, either these are error value or the extra value. Okay, or it, like my data ends here, but either maybe while downloading the data, or while let's say date only, I want a value from 2011 to 2020, but these are some value from 21, 22, 23, 24, 25 also got printed. Okay, so but I only want from this to this, my data contains only 2011 to 2020 values, example I'm telling you, and these are some extra value. While downloading the data, I got this values also till 2020, 26, for example. So this is not ending cleanly now here, it is having the trail. It's called the trailing garbage. Okay, the trail should end here, but we are having the extra rows which are not supposed to be there. So it is always important to check the last columns also, to check whether our data is ending properly or not. Right? Now these are the way to check first column and last column. Now if you have so many rows, okay, and you want to check some randomly, you want to choose any rows, okay, if you want to see the randomly the data you want to check. Okay, so to do that, it will, you can do sample 3, sorry. So what this sample will do, it will return three randomly chosen rows. Okay, like here now, and when I'll do shift enter, this rows will get changed. Okay, so in this way also you can check your data. Okay, like if it's having the useful, like it's useful for to see whether the data is representing, or to see a representative sample without always looking at the top or always looking at the end, but to check what are the mid values, or what are the generally my sample data looks like, or how the data is getting represented, like that. So it will randomly, sorry, returns three randomly rows, or a random rows. Okay, then another important thing to check, very important, two things to check after loading the data is df.info. This df.info is one of the most useful inspection method. It will print how many numbers of rows are there, each column name, how many none values are there, or nan values are there, what its data type, or like the where the data is missing, and all if I do df.info, it is going to tell me all the information, right? How many columns are there, city, country, and what are the null values. Okay, so there are like every values is the non-null value. So 2020. Then what are the object types, how many range index are there, means how many rows are there, how many total columns are there, right? So if you do df.info, you will be able to directly get this information using this info thing. So this is like the most useful inspection tool. Always to uh, dot info to check all these things, right? Another very important thing is df.describe. Okay, so what df.describe do, it will give us the maximum value, minimum value, number of counts, numeric columns, standard deviations, minimum, or we can minimum, maximum, 25th percentile, 75 percentile. Okay, so it will give the full statistical profile, right? So if I do df.describe and with open and close parentheses, you can see, uh, wait, which df it is given? This df is, uh, my df is this, no. Okay, yeah, sorry. Other things are object, no. Only latitude, longitude, and a population is the like the int in the float format. Other things are the object, no, string format. So there, that's why it's not calculating this mean, max, and all these things, right? So because this thing is giving us the statistical profile. Okay, full statistical profile. That's why only three column, latitude, longitude, and the population we are getting. Because for every numerical count, it is also important. For every numeric count, only for the numeric count. Okay, not for the data type of the string and the object. Understood df.info and df.describe? Any CSV file or Excel file or any tabular file you open, try, if you, instead of going with the df.head, all you should do to check how first file, if first file, first lines look like, or first rows look, how first file, anything look like, or last columns how it look likes, and what are the information we give here. If we, here it is like, important, because if you find anything none or nan value here, you can be easily able to see it here, and then accordingly you can like either delete that value, or either check what exact value that particular thing contain. Okay, So this is the df info, and this thing looks describe tells us. Now if you want to, now there are some other, like I told you, if you want to what to say, return your column names as a plain Python list. To do that, you will simply say python.columns.toList. So this toList will give us the all the column names, and it will return all the column names as the list. This is generally useful when we need to like programmatically literate, or like when you have to iterate something for over every column. Let's say there is there is a for loop you want to apply over every column. So during that time, it is important when you have to iterate something or iterate any program over a column names. Okay, so it will returns all column names as list, right? And if you want to check the number of rows again, either you can in the df.info you can get, or if you do len df, it will returns the number of rows, right? So number of rows are 20. Or another way to do is df.shape any uh, zero is that particular indexing, or we can say, and zero column, first column, or we are asking to give the shape. So all both the things are equivalent only. So this also returns number of rows, and this is also the same. In this way also you can check the number of rows, right? So this is how you will inspect the this thing. Just a minute, I'll check if yeah, okay, right. Now we have seen read and writing data. We have seen how to like the inspect the data, right? And then, and what else we have seen here? We have seen reading and writing the data, inspecting the data, and Boolean filtering, data frame, okay, reading and writing. Yeah, describing, inspecting, and all these things. Now, after this, another important topic is like the selecting the data. Now, there are two ways to select the data, either using the index or either using the position. Okay, so the next topic is selecting the data. Now, here there are two types, LOC and ILOC, right? So, when I say two primary indexer, these LOC and ILOC are the two primary indexer, that is LOC. And when I say LOC, LOC is the label based. Label based means those index label based 0, 1, 2, 3, and all these things, okay, which we get as a label. And if we say ILOC, this is the position based. So when I say position based, it can be in any column, it can be in any row. Okay. So we will see like if from this particular row, from this particular value, if I want to select anything, If I want to select zero label, I can easily select that zero label. But if you want to see that in this particular, let's say from this particular thing, I only want to select this thing. Okay. Or if you know, or if you want to say zero label, it means two label, it means it will give me the Mumbai and this particular thing. Okay. So let's consider, for example, this is labeling, and position based means, let's say I only want to print this three values. Okay. So I'll select the data position wise, and when I'm selecting the data label wise, I'll use the LOC. But when I have to select any particular position thing, then I'll use the ILOC. Okay. I'll give some 2-3 example, then we'll move to the um in the next class I'll explain about this thing deeply. Okay, let's say, okay, sorry, this is the markdown. Yeah, this is already okay. Now, for example, I have this DF. Okay, this DF contains what? City, country, population, latitude, longitude, and all these things. From this, if I have to simply select only one column, let's say if I only want to select the population, so if I do df dot population, I'll get that particular population will get printed. Okay, so what I'm doing, the single column selection with the square bracket and the string, writing that particular string. So what it is giving me, it is returning me a series, a single column with its index intact. Okay, with the index intact, right? So this is called single column selection. Okay, we are getting a series, right? Single column series plus index label. Okay, we are getting the index. Here we are not using LOC. I'm just telling you how we can create the single column from this particular data frame. If I write like this, df city, comma, dot, sorry, and population. Right? This double square bracket with a list of column names, it will return the, what it will return? It will return the same list of columns and column names and that particular row. So now when I'm writing double bracket, it is returning me a data frame. Here it was returning me a series, right? Now I am getting a data frame. I have a column now. I have a rows. Now I have a multiple columns. I can have a multiple columns. I can have a multiple rows. So this inner bracket are the Python list, and the output bracket is the Python selector, right? So what it is giving me? The double square bracket. This is single column. This is double square. It's giving me the returns data frame, right? With the multiple columns, and inner bracket is the Python list, comma, outer bracket is the pandas selector. Okay. Now for about LOC and ILOC. After this only we'll see how LOC and ILOC work, right? So that we will start from tomorrow. That how we'll select the data, and then again we'll move toward adding and modifying the columns. And so many things we'll see how to handle the CSV data and Excel data, all these things. Any doubt?
Oh, Sakshi, please ask Nagendra ji to share that file that you have shared on
He has
Google.
already shared, he told me. In the group also, he told that he has shared the input data file.
No, in the batch 5, we didn't get.
In the batch 5, you didn't get?
Yeah.
Acha. Okay, I'll talk to him.
And one more thing, just like we have learned a lot of things,
Hmm.
and I just want uh, everyone, I think, want that some tutorial or some
Yes, yes, I
assignments
will.
on which we can work so
Ha,
we
I
can
will give.
get practical insights.
Yes, yes. Actually, I was about to give on Friday only, but I was not well for 2 days. I'll give it now. I'll after the class, I'll just
Because I think when we will apply all those things, we have to club multiple things. I think there will be dictionaries, list, and
hmm,
all those things in one single code.
hmm,
So getting the idea on a individual
hmm.
level, it will enhance our
Yeah,
knowledge. Yeah.
sure. I will share.
Okay.
And by the end of this week, you can on Friday also we or else on Friday we can discuss, or on next Monday we can discuss the solutions and
Sure.
all these things,
Sure.
right? Hmm.
Okay.
Okay, guys. Any doubt?
No.
No, right? Okay. Then see you tomorrow. Bye bye.